A lot of people have been comparing EOS to Ethereum lately, and what they usually do is pick one or two small details, make a whole bunch of assumptions, and call it a day. I think in order to fairly and fully compare the two platforms, you really have to take a high-level bird's-eye view on the concepts. You will see that they are both a lot more similar than you may have originally thought and solve the same problems just in different ways. First, let's try to put a definition on both platforms and make sure we have the necessary background information before we dive in. So what is Ethereum? Ethereum is a protocol/platform for running decentralized blockchain applications through smart contracts. Its goal is to be a single or main universal and generic blockchain with its own programming language. EOS, or EOS.io, is an operating system-like software that allows for the creation of decentralized blockchain applications through smart contracts. It is important to know that EOS.io is the name of the software, while EOS is shorthand for the name of the blockchain created by the EOS.io software. Anyone can use the EOS.io software to create their own EOS blockchain. For consistency's sake, everyone refers to the community-launched EOS.io mainnet simply as EOS. So those are good definitions and all, but you probably wonder, what is a decentralized application and what is a smart contract? To answer your questions, let's first look at what is a decentralized application, or dApp for short. A dApp is a software application right now on the web, possibly mobile in the future, that connects and interacts with a blockchain via smart contracts. Because your application is now based off of a blockchain, you gain many new features that normal web and mobile applications do not have. Those include users are now able to have full ownership over their data. It removes the need for a third party. Users can now directly interact with each other without requiring permission. It is trustless. You gain full transparency and improved security because all transactions can now be fully audited at any time. You gain distributed computing and any other blockchain benefit. So how are dApps made? Well, they're made up of smart contracts. So why smart contracts? Instead of creating an individual type of transaction for every separate thing you want to use a blockchain for, you can write code to express whatever type of transaction you want. Ethereum did not invent smart contracts, but they were probably the first to bring them mainstream. Originally, Ethereum smart contracts were an entity of code where you could send Ether, aka money, to, and the code would then use its logic to manage that money. For example, the code could decide whether it would send the money back to you after something happened, send the money to another individual, send the money to multiple parties, send the money to another smart contract. It could even destroy the money. Smart contracts could basically do anything that you program them to do. Now eventually, smart contracts became even more generic, where they could manage any digital asset. For example, a like, if you were to think of an app similar to Facebook, they could manage votes, pictures, blog posts, artwork, any piece of digital data, as well as other computer programs and other smart contracts. A good example of a decentralized application is Steemit.com, which is built using smart contracts for the Steem blockchain. So what does a dApp look like? To the end user, probably like any other web or mobile application. This is because they still use similar interfaces that we use today on the web. A good way to visualize the quote-unquote dApp stack is as follows. At the top, you have the front end or user interface. Next, you have a smart contract that handles all the decentralized logic and computation. Then you have a storage provider for storing files that would be unnecessary to put on and hog the blockchain. An example would be the interplanetary file system, which works like a torrent, where you can look up content based on an address. Therefore, you just have to store files based on that address instead of the entire file itself. And finally, at the bottom, you have the blockchain itself. So now that we know that, what is the difference between Ethereum and EOS? From a glance, they look like the same thing, right? What I have done is broken up many of both platforms' features into the following categories, which we will explore in the next few slides. To start off, let's look at software execution. In Ethereum and EOS, every contract belongs to an account. and account send transactions back and forth. In Ethereum, all transactions are processed inside a virtual machine called the Ethereum Virtual Machine, or EVM for short. Contracts get compiled into bytecode and executed, kind of like Java in the Java virtual machine. Every single execution of this bytecode can then interact with the Ethereum blockchain. Developers write Solidity, which gets compiled to bytecode, which then runs on the EVM. In the future, there are proposals to use WebAssembly, which will allow developers to use broader choices of languages. Today, the EVM is single-threaded. EOS acts more like an operating system. This gives developers a bunch of useful features by default that they can then choose to use or not. This is different than Ethereum, where Solidity is a new language and many of the features must be written by the developer community from scratch. Developers write C++, which gets compiled to WebAssembly that then runs directly on an EOS processing node. EOS will be multi-threaded. At the heart of every blockchain is its consensus algorithm. Since arriving at consensus is arguably the most important aspect of blockchain technology, the consensus for both chains must be critically evaluated. In Ethereum, the consensus algorithm will be moving from proof of work to proof of stake over the next few years. To do so, they will be using a smart contract called Casper. With Casper, miners, or block producers, are now changed to validators, who will vote for blocks in order to maintain the chain. These validators are rewarded proportionally to the amount that they have staked. In this case, the more you stake, the more you are rewarded. Since this eliminates the overhead for mining, i.e. ASIC hardware, it allows more people to become validators, thus becoming more decentralized. It is important to note that there will be a minimum amount of Ether needed to stake to become a validator. At first, this will be around a 1,000 Ether, and hopefully more like 10 Ether once sharding gets implemented. If you don't know what sharding is, I will go over it later on in the slides. Because of this barrier to entry to become a validator, staking pools may become popular. One staking pool is Rocket Pool. Moving on to EOS. EOS defaults to delegated proof of stake with 21 block producers. It is important to note that this is just the default consensus implementation, and like Casper, it is implemented in a smart contract. That means that the consensus algorithm can be reconfigured to use different number of block producers, or even swapped out entirely with a different algorithm. Since the EOS mainnet looks like it will start out using the default configuration, we will examine this further. In the EOS delegated proof of stake, block rewards are split up into a per block reward, a dynamic per vote reward, and a worker proposal fund. The 21 block producers are not rewarded based on their stake, but rather receive a flat rate block reward that everyone agrees/votes upon. This is the per block reward. Then the total top 121 active block producers and block producers in waiting will all receive a per vote reward, where again, the reward is not based on their stake, but rather the amount of votes they have accumulated. And finally, the rest of the rewards go into a worker proposal fund, which will be used by the EOS mainnet community to pay for future chain proposals. It is important to note that these proposals can be anything, including proposals to burn the worker proposal fund, thus reducing or even eliminating inflation. Due to the consensus algorithms we just mentioned, one might conclude that Ethereum is more decentralized and EOS is in fact more centralized. The reasoning for this is as follows. The goal of Ethereum is to have no barrier of entry to become a validator node. Even laptops should be able to run it, and ASICs give no advantage. This could be considered the highest level of decentralization as long as there is no collusion. This requires Casper and switching to proof of stake. EOS delegates block production to a select number of entities through voting. This is much less decentralized, but more efficient since you can count on reliable block producers validating 24/7 and not laptops that may leave the network at will. It is also important to note that the transparency of these block producers is critical and collusion must not exist. We will have to split the topic of scalability into multiple parts since there is a lot of information to cover. We will start by looking at the two most notable scaling proposals for Ethereum, Plasma and sharding. First up is Ethereum's Plasma. Plasma essentially allows the creation of child blockchains from the main chain, and then the ability to create other children from the first children, and so forth. Here's a quick graphic I drew where the Ethereum main chain is at the top, and then Plasma creates child chains from the main chain. And then more child chains are created from those chains, and it keeps on growing. The best analogy for this is the court system in the EOS, where the Supreme Court is at the top, but does not take every case. Instead, there are many smaller local courts that rule at the local level, and when an issue gets big, it gets pushed up to a bigger state court, and then to a bigger federal court, and so on. In Ethereum, instead of clogging up the main chain, you can just use smaller side chains, and whenever a conflict does happen, it can be pushed up the chain and finally committed to the main net. This lets the Ethereum mainnet act as a power that only gets used when it has to. It also enables inter-blockchain communication for the chains to pass information between each other. It enables private blockchains, but since they will be children of the main Ethereum chain, the private chain still has to play by the Ethereum rules and will be held accountable if they break those rules. This way, users can trust the private chain because they know that the private chain must follow the Ethereum rules at the end of the day. With Plasma, you can theoretically get infinite transactions per second. However, the potential issue with Plasma is that a 51% attack is possible on a child chain because the hashing power gets split when the chain splits. Changing to proof of stake could mitigate this. I personally think Plasma is a pretty good proposal. It also needs mention that in EOS, although there are many different chains, they can all be produced by the same elected block producers, thus always requiring a 2/3 majority for an attack. Next up is sharding. Before you can understand why sharding is important, you must know that right now, every blockchain node needs to process and store every transaction. Also note that this is true in EOS as well. This adds up over time because the blockchain grows to storing many gigabytes worth of data, and although storage gets cheaper over time, downloading the entire blockchain to every node is not practical. Sharding splits the blockchain into a bunch of smaller nodes that only deal with a certain section of the blockchain instead of the whole thing. Each section is called a shard, and all the shards together make up the complete blockchain. Shards would be able to communicate asynchronously, i.e. not time-dependent, with each other. This requires EVM execution to be parallelizable. EOS has much of its scaling already baked in. EOS's main scalability feature is inter-blockchain communication. This is where multiple blockchains process all transactions in parallel, independent of each other. It also separates authentication from execution of the code. All of this is made possible through the utilization of parallel processing. This theoretically reaches infinite transactions per second. Let's talk about tokenization and what the tokens or cryptocurrencies are used for on each platform. Please note in the following examples, I will use the term account to refer to an entity that is using/interacting with a blockchain. An account can refer to a user or even a dApp itself. When referring to EOS, an account can be owned by multiple users. This allows an account to act like a business or organization owned by a group of individuals. There are many more possibilities, but for simplicity's sake, you can think of an account as an entity using the blockchain. Okay, so in Ethereum, every transaction and execution down to the opcode costs a fee called gas. This means that every time you want to interact with the blockchain, you will have to pay Ether. The primary reason for this fee is to prevent spam on the network. Transaction fees are common characteristics of many blockchains. Unfortunately, it also means that contracts cannot perform infinite loops, i.e., programs can't run forever because they will eventually run out of gas. Also, if a transaction fails, it still gets recorded on the blockchain and the account still pays for the transaction because a miner still mines the failed transaction. As an example, even if an account doesn't specify enough gas, the transaction will fail. Ethereum wants to keep a record of everything, including failures on its blockchain. On the EOS mainnet, the amount of network bandwidth an account gets allocated is based on the amount of tokens they hold. Therefore, transactions are free as long as you hold a couple of EOS tokens. Furthermore, the amount of storage and processing power an account gets is correlated to the amount of EOS tokens they hold. If a transaction fails, it does not get pushed to the blockchain and is not executed. Note that even though there will be multiple EOS chains, they will all use the same native EOS token for pricing, but the price may change from chain to chain. So some chains may be cheaper to host your decentralized application on than others. And this brings us to our next topic, governance. In Ethereum, code is the law. Transactions are irreversible no matter what, including theft. Improvements are made to Ethereum based on EIPs, or Ethereum Improvement Proposals. A relevant example of government on Ethereum today is EIP 99, which wants to restore the parity contract, and EIP 867, which is to create a new type of proposal called an Ethereum Restore Proposal to use in the future to deal with contract restoring. Since code is considered the law in Ethereum, there's a lot of contention between these two proposals. EOS, on the other hand, takes a different approach to governance and has taken quite a few measures to effectively address it. Unlike Ethereum, EOS believes that it is impossible to write bugless software and therefore code cannot be the law. I will break EOS governance into three highlights, which are Ricardian contracts, arbitration, and the EOS Constitution. A Ricardian contract is a human-readable contract in English that states the intent of a smart contract and what it should do. Therefore, if a bug arises from the contract, you can clearly see what the intention of the developer was, and there is no ambiguity around the bug. Contracts can be frozen by block producers if bugs occur. This can be viewed as the first line of defense against theft. The next line of defense is arbitration. If a smart contract and its Ricardian contract gets contested, or you become a victim of theft or some other lawful action, you can bring in a third party of your choice to arbitrate on a case-by-case basis. Arbitration will exist on the smaller scales, such as DACs or DApps, and on the larger mainnet scale. To briefly sum this up, if, for instance, you're using a DApp and someone cons you, you can bring in a local arbitrator of that DApp who is already familiar with all the DApp-specific rules and can help you retrieve your funds if they deem what has happened to be unlawful. The same can be said for larger scale contracts. Instead, you might want to hire a professional arbitrator if the case is very complex. In EOS, all transactions can be reversed through arbitration. Finally, there's the EOS Constitution. All users of the mainnet have to sign the most recent constitution and then hash that and include the hash on every one of their transactions. This proves that everyone agrees to all the same rules. The constitution can be changed and amended through a voting process. Right now, this is a work in progress being driven by the EOS community. You can create your own specific constitution for your DApp, and it will be nested inside the main EOS constitution. One widely criticized aspect to EOS is that block producers could pay token holders to vote them in. It is very important to note that the Constitution prohibits paid for voting, and if anyone is caught paying for votes, they will be removed as a block producer, have their reputation destroyed, and have to pay a financial penalty. The last thing I want to touch on is security. Both Ethereum and EOS are ZK Snark and multi-sig compatible. In EOS, accounts can be set up to use delayed transactions and permission schemes, which means if you get hacked, you can set a time delay before the money can be fully sent. And you will get notified immediately, allowing you to freeze the account and stop the hacker. There is also password recovery and the ability to have multiple authorization, like two-factor, when moving funds. So why do we have two platforms instead of one? They both seem like they are trying to achieve the same goals. What it really comes down to is the philosophy behind each project. Ethereum believes that you cannot trust anyone, and we must use game theory and crypto economics to incentivize people to get along with each other. On the other hand, EOS believes that the vast majority of people have good intentions, and it is better to have human intervention than solely relying on computers. In short, Ethereum is a public blockchain for the new decentralized internet. It is also important to make the distinction that EOS.io is an open source software that enables anyone to create their own blockchain and blockchain applications, while the EOS mainnet is the result of a community of people coming together and releasing a public EOS chain for anyone to use based on the EOS.io software. Remember that with the EOS.io software, you can create any blockchain you want with any configuration you want, including private chains. Here's a quick graphic I drew showing the EOS blockchains. Here you have multiple different blockchains that can communicate with each other, and even private blockchains that have the ability to communicate with the public blockchains if they so choose to. Here's the Ethereum mainnet, which uses sidechains and other second-layer scaling solutions to scale, but still rely on a single Ethereum mainnet chain. If you've made it this far, I would like to say that this is, of course, my own personal perspective on both projects, and you are free to reach your own conclusions. I think in a perfect world, both Ethereum and EOS should be able to communicate and interact with each other. Therefore, Ethereum chains, EOS chains, and even things like NEO or BTC chains could all work together interoperably. Again, there are things that I did not cover in this video as I just scratched the surface, but I hope I have given you some insight on both projects and you can now conduct your own research. Thank you for watching.